Momenteel varen schepen op diesel en in internationale wateren zelfs met zeer vervuilende bunkerolie. Dat moet veranderen, zegt ook de International Maritime Organization. De IMO stelt dat in 2050 de CO₂-uitstoot met 50% moet zijn verminderd. Om dat te bereiken moet er dus gezocht worden naar een alternatieve energiebron, zoals accu's of waterstof. Of beide. Dat is exact wat ze met de Energy Observer gedaan hebben. Het is een oude zeilboot die omgebouwd is en nu geheel vaart op waterstof. Hij ligt nu in Amsterdam en wij gaan even kijken.
We started in 2017, and we're sailing up to 23, going almost everywhere in the world. And our mission is to showcase to the, to the authorities, to the local administrations, that the hydrogen is safe, quite simple, and affordable.
Sustainable energy, why is that important for ships?
Because the ships are among the biggest polluters in the world. You know that we know that the 50 biggest ships emit the same amount of fine particles as the whole car park in the world. You know, so we have the shipping industry is very polluting, especially in harbors and on the coastline. Where you have a big concentration of population, so that's a big issue.
De centrale hub van het schip is deze schakelcentrale. Hier komt alle bekabeling samen, van bijvoorbeeld de zonnepanelen, de accu's en de brandstofcel. Op 2 schermen is alles te monitoren. Hier zie je bijvoorbeeld in het rood welke groepen zonnepanelen zonlicht opvangen en hoeveel stroom er gegenereerd wordt. In dit geval zitten de accu's vol, dus zijn alleen de achterste panelen actief en is de rest uitgeschakeld. De accu's en waterstoftanks worden in het groen weergegeven en zitten voor de balans aan weerszijden van het schip. Per zijde 4 waterstoftanks van 3,5 meter lang en accucellen met een capaciteit van 50 kilowattuur.
Then you have the different layouts of the different systems. This is a 400 volt. Production and consumers. So you got the 2 engines, the fuel cell, the electrolyzer, and the compressors. You know, because we compress the hydrogen that we produce on board, we compress it up to 350 bars to put it in the tanks. 350, it is the same pressure that you find in any hydrogen bus. You know, there are about 300 of them. Running in Beijing, in China, you got some of them in London, on the west coast
even
of the US.
Even in Groningen.
Even here, in the Netherlands, and the norm is 350 bars.
Yeah, right. And 700, because some cars have 700 bars. Is that possible? Or is
it's possible, but because in a car you've got less space than in a bus or a truck or a ship, so they need to compress it more than 350. But on boats, if you go up to 700, the strength and the weight of the tanks is much higher because they have to be thicker, so they are heavier. Yeah. So it's always a matter of compromise.
Zonnepanelen vormen de belangrijkste energiebron van het schip. Het dek is voorzien van 130 vierkante meter aan zonnecellen, goed voor een capaciteit van 21 kilowattuur. Er worden 3 verschillende soorten panelen gebruikt.
So you have this type, it's an anti-slip, very light, flexible, and they are very strong. We have tested them in the Mediterranean with very, very high temperatures in Israel, in Turkey, in Tunisia. So it's a cooperation with Solbian. Solbian is an Italian company producing the casing. The cells come from sun power, and they are very efficient. They go up to 22-23%, even if the sun is quite low on the horizon.
And even they are curved, and that's no problem?
Yeah, no, absolutely not. And the design of the casing, makes that even with a very low sun, they are still very efficient. Then you have these prototypes here that you see on these wings. They are double-faced, heterojunction, so they are very efficient, up to 25-26%. but they are prototypes. You know, we work on them all the time. And you've got these glossy ones, you know, on the tanks covers. They are even more efficient than this one, but they are more demanding in terms of the position of the sun has to be very perpendicular to the cells.
How long can you stay at sea with batteries and hydrogen?
With only the hydrogen, we can sail for about 5 days with no sun and no wind. After 5 days, we need to slow down and to produce some more hydrogen and then to start again. But with the new wings that we are going to put on the boat next week, we will be able to electrolyze while sailing. So that's a big step forward for us because we need to cross the Atlantic and the Pacific next year to go to Japan, and we definitely need to have some help from the wind. Yep. They are not making directly energy; they are pushing the boat, and when the boat is sailing, let's say at 5 or 6 knots, the propellers are used the other way around, and they produce electricity. And this allows us to keep the solar power to electrolyze, you know, so that's a double advantage. First, you produce electricity with your propellers because they turn the other way around, and secondly, it lets you enough energy from the solar to be able to electrolyze while sailing.
Er zijn 8 waterstoftanks aan boord met een totale capaciteit van 62 kilo, goed voor circa 1200 kilowattuur aan energie. Ter vergelijking, een waterstofauto heeft een capaciteit van circa 5 kilo. Het waterstofgas wordt door de brandstofcel omgezet naar energie.
We are in the right hull of the catamaran, where we have the fuel cell and the electrolyzer. So that's the zone where the electricity is produced out of the hydrogen tanks, which are just above us, and where the water is converted into hydrogen. Okay. So this zone is kind of protected because it is an ATEX zone, and there is very strictly controlled atmosphere, humidity, pressure. So that's an ATEX zone. So we cannot open it when the fuel cell is working, even if it is not so dangerous. There is no danger at all. But
when it's working, there aren't any people allowed here.
No.
For security reasons.
No, for norms reasons.
Oh, for norms, okay.
You know, because there is no leak, absolutely no leak. As soon as there is a single leak of air, oxygen, or hydrogen, or whatever, the system just stops.
Because this system is it kind of similar that buses use?
Absolutely the same, except for all these equipments, and all these tubings that you see here and here, because we are engineers and we want to get the most out of this system in terms of energy, heating, calories. So we use the heat of the fuel cell to store the heat. We use the electricity. Sometimes we have pushed the efficiency of the fuel cell up to 60% instead of 50%. We test different temperatures. In Israel we had, and in Tunisia we had up to 45 degrees Celsius outside, so it was more than 60, 70 degrees inside this compartment. So we made a lot of tests, and we had to modify slightly the cooling system. And we have a system to heat up the fuel cell before starting when it is very cold outside, and a system to cool it down when the weather is very hot.
De Energy Observer is een varend experiment waar continu aan gesleuteld wordt. Het moet een voorbeeld zijn voor de scheepvaart om meer duurzame energie te gebruiken en schadelijke uitstoot te verminderen. Maar kunnen daar dan ook de beoogde CO2-doelstellingen mee worden behaald?
Yeah, that's achievable if we invest in this kind of new technologies where it's not a dream. I mean, on the short term, what we can do is to use the hydrogen mixed with diesel, like the CMB, the Belgian company do. They inject hydrogen into the combustion engines, and Within the next 2 or 3 years, there should be some high-power fuel cells. You know, the European Commission is investing a lot in these new technologies, so we can see bigger and bigger ships in the near future using this kind of hydrogen fuel cell or combustion engines. But no, the technology is very mature now.